Oh god. So if S is a finite subset of R cubed, then I want to construct a system that omits exactly... Oh, Jesus Christ. So I know how to do it when S is the empty set. Is R a join? Wait, what? No, this is the ring of polynomials. Like it's 3 variable polynomials. Okay. So I don't even... Can I get something for the origin? I want to start with the origin. It's probably going to be something really crappy like, hang on. Have I seen this before? Can I get a PQR that... Arbitrary finite set. I don't think you can get all sets. I might get those words, but finite's probably pretty important. The thing is, I don't know how to... So what's a polynomial system for which the only thing not in the image is the L0? It is reals, right? Like... No, it's PQR depend on the set S. Here, I'll write fix a finite subset. How do I miss only the origin? Plus, no. I mean, I'm just spitballing crap. Like it has to be something where if one of the numbers is 0, if one of the numbers is 0, it needs to like flip into a switch of something, right? Like there's some sort of switch that occurs, and then I only want all 3 of them being 0 to cause problems. Oh jeez, I don't know how you do that. Yeah, dude. So X, Y, and then and like some product of something, right? So I want it to be such that so okay, well, a long time ago there was a Putnam problem with some range. Let me see if I can remember it. Like 2 variable polynomials had some sort of or not two variable. I'm trying to remember now what that problem was. It was an ancient Putnam problem that I put in, I think, anti-problems or something like that, about what can the range of a two variable polynomial be or something like that. What was it again? So something of that shape. I can't remember anymore. $1969.81, thank you. See, now I wish I had like 4 variables or some crap like that. Okay. That doesn't let me change signs easily. Does this do anything? Oh, someone already has one. Okay, thank you. I'll take that. Okay, so the claim is this thing can hit everything except the L0 tuple, maybe? I have no idea why that would be true. Yeah, I mean, also this is not what I want, because this actually hits everything that. So okay, if I do x squared plus x. Oh jeez. It doesn't work. Okay, never mind. I'll drop that one. Dude, what am I gonna do once S is a set with more than one element in it? So, okay, if I could do this for a single thing, is there a way I can put them together to get a finite set? I'm not sure I can. I could try to do something like the product of like I don't know how to get a finite set, and I don't know how to stitch multiple sets to points together. Actually, maybe multiple point. Like, suppose I could do it where, do I compose them? Like, if I have a thing that whose image is everything but a point, can I propagate it? Like, keep applying the same instead of. If I can omit a point, can I omit a second point by composing it with itself? Only if it was almost like. I think maybe I could compose it. I guess it depends on the way that you do it. If I can get a bijective one, like a bijective solution to this, then maybe I could rig it such that if I had another point that I wanted to get rid of, well, it should be easy to make polynomial bijections, right? That part shouldn't be hard. In fact, yeah, no, that part should be easy. Like if I have, maybe. So I feel like what I want, I mean, I still need I need a gadget that lets me kill one point exactly from the image. Once I can do that, then I can take that as the new domain, and then apply some transform on it maybe, and then do it again. And then maybe that'll let me kill a second point. It's like it's like f of the omitted image, and also like the thing that you can't get with f. So if I that might get me from single to. Okay, and then someone thinks they know how to do. What the frick is that? Okay, Twitch chat says xy minus 1, x to 4, xy minus 1, x squared z squared plus y. Z? So the claim is I can get everything that isn't the origin. Do I believe that claim? What the frick is this? Not. What? How did? Okay, I won't ask too many questions. If two coordinates equal 0, well, I mean, really, the only case I really care about is, I just need them to not all, but why is this surjective? Like, why can I hit every point with this, other than the origin? Why is this almost surjective? I also want to keep thinking about, because we do need to compose this with itself eventually or something like that. How do you get everything except the origin? Does this actually work? if I want to, I mean, z's can be any number, and then I need to show that except for, well, z equals 0 is a special case, actually. Like, I need to, then I need a, I wonder if I should be doing the 2D version first. Hmm. Actually, I think this is just, no. Yes, no. Wait, what? Like, I can see if this guy is 0, if you fix this guy... Okay, if z is 0, okay, I don't know what's going on. If z isn't... No, yeah, no, it's okay, yeah, okay, maybe this works. If you fix this to be some number, I mean, you can always, like, a plus 1 is fine, and then z is c. So, the only way... Well... Yeah, okay, I understand. So is this a... Is this almost a bijection? Maybe that's my question. Because if it's almost a bijection, then... Like, if it's a bijection from space to punctured space, then we should be... then this will actually be almost there. If this is actually a bijection from space to punctured space, then I should be able to chain this to get random. Yeah, you should be able to chain it. Okay, so let me write the system as it is. So the system reads A is xy plus 1, and then B is equal to and C is just equal to Z. We're just going to drop Z altogether. So we'll just square it because why not? So if here's my system, so when A equals 0 and C equals 0, then B can be anything non-zero. If like let's say no, but this can't, no, because why is what am I trying to say with the bijection thing? I want to say that node 2xy will... Wait, now I'm confusing myself. So it's like C is fixed, but then... So it's if A, B, C are fixed, I want there to always be exactly one... I want there to always be exactly one xy for that system. Well, on the other hand, so it's a... So if either A or C is non-zero, then it's an even degree polynomial, and so there's like only... For fixed ABC, there's like a few choices of x, but every choice of x will lead to a different choice of y, unless A is equal to 1. If A is equal to 1, then... In fact... If A is equal to 1, then y has to be... Either x or y has to be 0. So either b equals y, or... So is it almost surjective? So there might be a problem with... Okay, let's call this thing f. I'm a little more optimistic about this f now. Where, okay, so f of... It doesn't really matter what z is. So it's never equal to 0. And in... As long as A is not equal to 1, if A is not equal to 1, then a choice of... Right, so what I can do is that you can determine like up to... You can determine a small number of... The second equation when I multiply it by x tells me A dot times x to the 5 c squared times x cubed plus x a minus 1. So it means that x comes out of a quintic, up to a quintic equation in... in whatever it is. And then, so unless a equals 1, there's up to 5 choices of x, but each one will yield a different value of y. Wait, actually that's bad. That means it's like 5 to 1. Right? Hang on. I think I just checked. Okay, I think I just showed that it's not. It is in fact not injective. Or not surjective. Or, sorry, what's the word? It's certainly surjective. What am I trying to do? I keep losing track. So, okay, the point of this construction is that it's always... It is surjective onto everything deleted with the origin deleted. Because I can pick A, like for every choice of C, it's a degree up to... Yeah, that part is fine. And then... Fine. The question is, can I... So if I have this function f, it's not injective because certain xyz pairs will give me the same output point. Yeah, but I don't... I was hoping for bijection onto puncture, but I think that's too good to be true. On the other hand, if I have a... Okay, so let me actually write things down instead of just saying them. So f is... well, we'll just write bf0 is injective. Sorry, is surjective. And also f, like, actually omits the origin. We don't really need bijection, you might be right. So now if I have a point P, so suppose I now have 2 points, like P and the origin, how can I omit them? And it's like f of... Oh, okay, it's at most 5 to 1. That might be the trigger. It's surjective, and for every point P not equal to the all 0 point, at most 5 preimages f of q. One for every choice of... So let's see if we can get 2 points, and if we get 2 points, I think I can then push it all the way to let's see if we can get 2 points. All right. Suppose we want to omit 0 and I should be a good person and type mathbf because bf is a deprecated command. Then let mathbf q1 be the preimages of P. So, okay. So if I take like f... Oh, Shiba. Hey, is there a reason we needed c squared here instead of just c? Like, do I need a square on the z? So okay, actually I'm not gonna, sorry, really only 0 should be in bold. I don't need to bold the others. So, okay, if I take f of vector plus p, then like what does this do? This omits every point except, let's say q1, all right? And then if I apply f again, that doesn't, okay, so if I do it this way, this doesn't help me, right? Because, that's fine. So what I really need is I want to look for regions for which I know this polynomial has exactly one root. So, oh jeez. Is that why I need, so in that case, I'm gonna drop the square. I don't think I need the square for this argument to work, and I think it's gonna get in the way if it's there. So what are conditions that are good enough for me to for this polynomial to have exactly one root? So if I do this, so if P is a unique preimage, then that's fine. And also, let T be a linear transformation such that T of P, such that T of P prime is P and P prime has a unique preimage Q. Like linear is actually linear algebra, right? So then if I chain this construction, what did I do? So I think we can, okay, I think I got 2 points because there should be a lot of different values of, because it's only it's just a sign thing, right? Like we expect like, there's choices of ABC here. And as far as linear maps are concerned, 0, 0, 0 is special and every other point we don't give a crap about. So hence for every, so we can omit any 2 points we want. So we had a gadget that lets you omit 1 point, and now we have a gadget that lets you omit 2 points, any 2 points. So finally, so then let G be a gadget. So suppose we want to omit 0. I don't know if I should be giving that much special. Am I making it harder for myself by calling one of them 0? So let G be a gadget omitting only P and Q. Oh, okay, but now the thing is I need to actually think a little bit about the... Oh, God. Yeah, bijection would certainly make life easier, but I doubt it exists. Like, I don't believe... Because now G is not explicit, right? So I don't necessarily know that G has points that appear exactly once. Because if it did, then I'm fine. I could shift. Ah, crap. I think we're getting closer. I need to think this a little further. What if I do it in the innermost? If I have T and F as the outermost, and then G of V plus something. So let me think what I want to omit. So we're gonna... Yeah, I think I'm making life harder for myself by calling one of them 0, because the special thing I actually want to not be... Hang on. So PQ... I'm just going to call him PQR and see what happens, alright? So we'll let T be a... Oh, shit. Damn it. No, okay, we're gonna call one of them 0. I changed my mind again. Well, no. Suppose we want to emit 3 points. So I'm just gonna copy. Let T be a linear transform such that T of P prime is P and P prime has a unique preimage Q. I should call it P prime prime. So then if I do G of V, it's something like this, right? It's like one of the points... Ah, shit. Dude, this notation is horrendous. Okay, let's actually write the induction properly. I think this is going where I want it to go. I think I can find points such that F, you know, there's only one point up there exists a lot of points. I'm just gonna say there exists infinitely many points. There exists infinitely many points such that F preimage unique preimage above it, right? And then claim for every S there exists gadget, well, we'll call it G, omitting only elements, exactly elements of S. And proof, this is for finite. So for S equals 1, use G equals F plus the vector you want to omit, right? Okay, so now suppose S is, so there's gonna be one new vector and then n minus 1 vectors I don't like. Call it GS. So without loss of generality by linear transform, without loss of generality v equals 0, and then by linear transform, assume also, because I can take any non-zero vector to any other non-zero vector, assume that F has unique preimage above V, right? So now what I'm going to do is I'm going to choose GS. So I'm going to use F once and Okay, so this is where the problem is. Because if I have f on the outermost, I cannot easily omit. Wait, hang on. What am I trying to omit? So f omits. Sorry, hang on. No, 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 no. So f omits everything but 0. So the special bad guy I really want to be plus v here. So then what do I put in here? And where did I use... Hang on. Oh my god, I'm getting so confused. It should be this. This feels right. I think I want GT to be on the outside, right? No, but now the preimage isn't. Ah, crap. No. Oh, is the square actually necessary? Shiba. Okay, that's fine. We'll live with the square. Oh crap, yeah, you're right, we actually need a square. Okay, how about I do the following? I'm going to add on a new inductive hypothesis, and also with infinitely many points at which GS is surjective, or injective. So it should be an infinite set for which I can, yeah, great. And then here I can, without loss of generality, v is not equal to 0. Where v is not the 0 vector. I'm running out of letters. By inductive hypothesis, there are infinitely many g. Okay, so we'll let t be vi minus v. Oh, but now I can't. Ah, this is so sad. Because if I do a linear transformation now, it like the set of infinite points depends on. Oh, fucking hell. Oh, that's so finicky. So this would almost work if, right, and then I mean there's I really don't want to bring in hypervolumes in, but I think that might be what I need to do. Where like the set of points for which above which f is injective, you know, has some measured theoretic density. It's like there's it's a I don't know what that shape looks like. It's something. God damn it. Like what's the set of ABC for which this really has a unique root? Okay, does anyone remember what Descartes' rule of signs says? Because I cannot remember that theorem statement for my life. I want an explicit result that tells me for which ABC this quintic is guaranteed to have exactly one solution. If I can do that, then maybe I can make it this explicit enough that I can carry out the induction. Isn't there a bound? It's not just a mod, because mod 2 isn't good enough for me, right? Like what I want to say is that, say, it's less than or equal to that number. Right. So if I can get a result that says, for example, that, well, okay, if A, B, C are all greater than 1, then it's fine, right? Like if I have a quintic whose coefficients are all non-negative, there's exactly one real root, is what the Descartes sign rule should promise me, right? That's well for this, yeah, because when I. Or even better, if I just let A equals 1 and B be. Like if a equals 1 and b is greater than 0. Right, okay, that's fine. So maybe the point is that I need to be more clear when I have unique preimage. I think a greater than 1... Right, so, okay, here's what I'm going to say. If a, b, c, if a greater than 1, c greater than 0, or c is not 0, and b is less than 0, then f is injective above abc. By Descartes-Wolf signs. Right. Okay, so if that's... then what I want is... I don't know what I want. That's a problem in life. So there exists a gadget GS such that GS omits exactly the elements of S, and also so what's a way I can say this is GS is injective across what? Something? I don't know. F in tangent, would F bijection imply it's homeomorphic? I didn't think that far ahead. Well, r cubed is not homeomorphic to r cubed minus 0, 0, 0. So what's homeomorphic? It's like, I mean, it's a continuous bijection with continuous inverse. If you have a polynomial, oh god, I forgot all this math a long time ago. That's the problem. I think I'm not sure whether such a map would necessarily have continuous inverse. It feels like polynomials are tame enough that probably the inverse is continuous. So yeah, I agree that probably means we cannot find a bijection. Okay, in fact, you know what? This thing is bothering me. So I'm going to just put a minus sign on this middle coordinate so that it's minus here. So we're just going to require that it's like an octant, alright? Well, I'm going to say if I'm going to make it injective above some... I don't know what you call it. I did have the same thought earlier that it was probably not going to be possible to get a bijection for topology reasons. So, yeah. Ah, yeah, okay, this is good. This is good now, because if I'm injective above C, like, this is some fixed number. So, So by scaling, oh shit, but dude, the problem is that this like G of T, it doesn't actually fix this dependency issue. Is it easier if all the points are on a straight line? I don't, maybe? I don't know. Like the thing is, I want to define G based on T, but I want to modify T based on G. So I keep running into this stupid dependency loop. It doesn't feel like it should be the deal breaker. Dude, help me finish this freaking. Oh my god, I'm so annoyed. It's like, it's barely. It's just this stupid dependence on this C. I can't. This can't be the. God damn it. So can I take C equals like 1? Can I just take C equals 1? Is that a thing I can do? I don't know, man. The other option is I can bake the constant into my notation. That could work. TM. So we're gonna oh my god, this is the dumbest thing I've ever done. Eta. We're gonna call this parameter eta because I don't know what else to call it. So we're gonna replace 1 with eta everywhere, alright? And then for every finite set S and every eta greater than 0, there exists a gadget G S comma eta such that it omits exactly the elements of S, and it is also injective for all things which are. Should I use a different letter than eta? What Greek letter do you guys all like? Someone's just a better Greek. I don't know. Does eta have a connotation of small? I don't think it does. Xi. Wait, never mind. Okay, but now my base case is in a little trouble, right? So g of s comma eta for a single element. If v has like positive coordinates, I'm in trouble, right? Because that will move the injective set to. Okay, so maybe I shouldn't require that eta is greater than 0? Because it's not. Oh, but okay, no. It does matter that this is a is positive. Oh, shit. So this base case might be in trouble. Oh, I can scale this thing though, right? Like I can put a scaling parameter on. I don't know if that helps me, because my problem is that I can put a scaling parameter on f, but that doesn't fix the thing. Because the thing is, like, I have a I need this thing to omit have a hole somewhere, right? Like this v is like there's a hole there, and then my injective region will always. I mean, my injective region that I'm trying to build can't pass through the hole. Wherever I puncture the plane, or not the plane, wherever I puncture space, like I cannot pass through a hole, so that's not good. How do I? So maybe instead what I should do is I should try to rig, because wherever I puncture the hole, I can put the octant in like 8 different ways, right? Like, but once n is at least 8, that might not save me. Well, there's a point with largest. Oh, shitting hell. I do need a to be positive for this argument, right? Because that's, if a is negative, I'm in trouble. So maybe instead of an absolute, maybe instead of x min xyz, what I really want to say is min of like to the points P, where I take the P against the coordinates of S. I don't even know how to write the notation for this. I just want to say so. Okay, I think this eta that I introduced on the capital F is probably superfluous. I probably can just replace this with 1 again, because I can just scale F anyways. But I might have to do it relative to the points. If so, this is greater than 1, and then I mean, I'm just not going to distinguish between the 3 coordinates. I hope that's okay. And then here, now I can write just F, right? So here's my gadget F. And then I just scale by eta, and that's fine. I'll just move the injective region a little bit. Right, and now I'm okay, right? Because I guess it's like I have a bunch of points in space, and I need one of them to be. I want them to be like a corner or something of that set. I don't know exactly what I'm saying. I think this should work. Okay, so at this point, I actually do want to replace eta with epsilon, because that is the correct connotation. I think the notation is going to be super annoying if I really want to do what I want to say. Well, I think what I want to say is the gadget should, it omits a set of points, and then it gives you an injective region in some. It's like there's a point and you pick one of the 8 directions, right? Like so either plus or minus, and then shoot. And then then it should omit. It should be injective over. So I don't need C to be non-zero for this. What do I want to say? Can I feel like it would be nice if I could just get the stupid +1 to work. Twitch chat, please help me out. I'm so lost with quantifiers right now. I'm gonna write the thing that I want. For every finite S and S, and so if S is a finite set of points in R cubed, and okay, so I used XYZ here, but I could take any linear transformation of these, right? Yeah, okay, I'm not going to restrict to 8. So if S is a finite set of points in R cubed, well, okay. If P is a if P is a point in R cubed, then I don't know what do you call this? Then an epsilon sheet or something? I don't freaking know. If I have a It's like, how do I draw this? Is array of is a I don't even know a word for it. Octant? We'll just do octants to keep things simple, okay? I don't think this will affect the argument. In a direction is a cube-shaped cone of light so where bold n is a unit vector is a I don't know what to call it. Like I have a point and then I want to whatever, it doesn't matter. The point is that I don't actually want to use XYZ coordinates because that will actually cause me problems later on. I don't know what you call this solid crap. Like if this was okay, whatever, it doesn't. God. So let S be a finite set, epsilon greater than 0, S and S affix a point, and non-empty finite set. Well, we'll just call it an epsilon zone. So do I need b greater than 0 for this? Because if I can drop the b greater than 0, that would, okay, no, there's no way I can get rid of that. Yeah, okay, I need b greater than 0. If I, no, actually, yeah, no, you can't get rid of that, that's fine. Then an epsilon zone is a quarter something. I don't even know what word to write. Then is a quarter zone is a rotation of the region x greater than epsilon, y greater than 0 around z, around p. Then there exists G S epsilon Z such that G omits exactly the elements of S and G is injective over for a suitable orthogonal matrix M. I cannot believe I'm doing this. This is the dumbest thing I've ever done. Okay, great. And now that I have a zone, now suppose V and V is where V is where V has zone. Okay, so now we can do the subtraction, right? And then also look at all the zones. Look at all the zones in the same direction. Shit, this almost doesn't work. This doesn't quite work. Because I am comparing two numbers and maybe there's a tie or something? My 3D visualization is not good enough for this bullshit. Holy fuck. What I need is one of the VI should have a zone that lets me cover V, and is also contained inside. Yeah, I can sort by x plus y plus z. Okay, I'm gonna, as a rotation of the region, I'm gonna just make this, I'm gonna keep this simple and make it min x, y, z greater than epsilon. So it's so it's like this like cubical, like you imagine you have a flashlight or some crap that shoots, I don't know. Now I look at all the differences. We can find a VI such that the epsilon and some epsilon zone such that the shifted zone contains only V and no other points of VI. So for example, in a coordinate system where the zone is really min x, y, z greater than epsilon, it suffices to sort by x plus y plus z, I believe. That might be a lie. Hang on, that might not be good enough. Shit. So I think if I want this to work, I really want the zone to be like half of the space instead of all of it, because then I can actually sort by a normal vector or some crap like that. Can I improve this so that it's a greater than epsilon and doesn't have dependence on B? I'm not sure I can. I can get rid of one of the parameters. I don't know if I can get rid of two. See? See, right? Because if you have half spaces, then it actually is. Oh no. The bending might cause it to miss. Like in R2, for example, if I have quarter things, so I really need half. I really need to be injective on half the things for this strategy to work. And I'm not sure I could get that. Damn it. If all points lie on the x-axis, that seems like a big constraint. Can we modify this construction like just slightly so that it's injective even when b is negative? Because if I can get it so that it's injective even when b is negative, then we're totally fine. Alternatively, I might not be able to do an induction with an infinite set like this. And it might be like I start with the set V and then I inductively construct it based on that set V, but after I've decided something. Dude, this is so desperate in so many ways. Yeah, the octants. Freaking. Yeah, this is close, right? Like, this is close because whatchamacallit? It's just this one coefficient. Oh man. I feel like I could solve this problem over R2, maybe at this point. Maybe not. Do I just drop like less equals 0? Yeah, like I might be able to do the problem over R2 at this point. That's so sad. That's actually sad. Oh, so I don't think I can do it over R2. I'm still missing a... So the other thing I can do is I see. One of the coordinates has a 1, the other has a 0. Okay, alright. Okay, we're going to do the following. Without loss of generality, assume all the x coordinates in S are different. And sort the vectors by x coordinate. So then we're going to do this inductively, as I promised. And with v1 having the greatest x coordinate and vn having the smallest. So I'm gonna drop all this. For each I equals 1 through n, there is a gadget there's a function gi such that gi omits exactly I don't know what to call it. Well, we'll decide the name later. But by rotation, say, and we'll let epsilon be smaller than any difference in x coordinates. But I think that the idea is I might need a picture for this. So G1 will just be F plus V. That part is okay. All the X, let's say all the coordinates indifferent, just so I don't have to worry about B being 0. Actually, no, it's fine even if, whatever, let's make them all different. There's no reason not to. So G1 is equal to F plus V, F plus V1. So So F might be a little twisted, and that's okay. I might need to be doing an F plus and an F minus. What am I trying to do? I want to get everything except. So the thing that misses V1 minus V2. Some unique preimage here. What am I trying to do? Yeah, I think it should be something like this. I don't want to open the whiteboard because it's so laggy and I can't do it in my head. So, all right, we're gonna open the whiteboard. I don't think I'm gonna solve it with a LaTeX board. I don't know. Right. So what's our situation? So we have a f. So we have our function f that we constructed. That's our initial gadget. And what does f do? F takes r cubed onto. Dude, this is why I didn't want to use the whiteboard. Oh my god, it's so hard to draw with the pen this laggy. Like half the inputs just get dropped. That's supposed to be an arrow. I promise that's an arrow. What does it do? It omits a point. And then it's also injective over either here, let's say, or I can have it injective any other quarter thing. So I'm gonna drop one of the coordinates is unconstrained, so I'm just gonna not draw a picture of it because I can't draw 3D pictures for my life. Alright, so great. So I can omit a point and then also be injective there. So next, what do I do? So now let's say I have a bunch of points, or let's say I have 2 points, right? And then what I do is I can take I can have my thing such that it's I already have this. It's like okay, let me so I can go here. I can center F here, and then it'll also be injective, like up to here, because that's within my zone. So to be clear, this only works for like half of it. So because that's true, then I can say this is going to be F of, let's call this one V2. And this is injective there. So I can put some other F here. The inner F I don't really care as much about. As long as it hits everything except the pre-image of this green thing, which is gonna be so here it's actually injective, and I can write F inverse of V1 minus V2. So this will work for like, okay, so I still, I'm trying to get F to be the outer one now. That's what I'm trying to do. But the issue is that like what if now I have a bunch of points? Let's say I have 3 points, and I've been trying to fix this axis this way. I can have an F, but I can't pick. If I'm constrained to be axis aligned, which I don't have to be, but I might run into issues once there's like 100 points. I can't be injective onto like both this guy and this guy at the same time. So I really, really want to see if I can get a version of F that's injective on half the plane. And if I can do that, then I'm okay. But I don't know if I can do that. Not with this setup. Right. Because this my Descartes sign isn't good enough here. So is there a way I can, right now the issue is that I have like I have like 3 different non-zero coefficients. One of them is c squared, so c squared is fine because that will always just be, c squared is fine because that will always just be positive. The question is, can I get, so why is there an x to the 4th here? Like, can I compress this so that there's only one non-zero coefficient or something like that? Like, what if instead of x to the 4th, I just had 1? Like just xy minus 1 here. Why is this here anyways again? I forget. Oh, because you need it so that if shit. Dude, I just want it to be injective on 1/2 instead of a quarter. I got it on a quarter of it. I need a half. Oh god. No. No. It's almost midnight. Am I going to get this soon? Am I going up the right path at all? I mean, this does feel pretty good. It's just I can't get the injective result I need. I need to be injective in a big enough region that I can iterate the result. Alright, I don't know, man. I need a, I have a quarter, I need a half. I don't know how to go from a quarter to a half. I do need, because I need it to be such that, right? Like, the point of this odd degree polynomial is that, the point of the odd degree polynomial is that it always has like a real root, unless it happens that all three coefficients are 0, in which case, if all three coefficients are 0, then it forces a equals 1, which isn't possible. The other thing I can do is there's linear. Okay, here's another idea. So I'm running into issues because I keep trying to restrict myself to these L shapes. But I don't have to restrict myself to orthogonal transformations. And what I can do is I can stretch them so that instead of an L shape, it's like an L shape won't work because it's too rigid. But what I can do is I can do this, make these very arced V shapes where this is 180 degrees minus epsilon for some epsilon. And because my set is finite, I ought to be able to pick an angle that's big enough to such that all of these lights will right? The problem is before that I had L shapes and I don't want L shape, and I kept doing that because that's what the construction gave, and I kept saying I want to get a quarter. I don't think I can get a half, but I can get a half minus epsilon if I'm willing to, you know, really stretch. Is that a thing you can do? That must be a thing you can do, right? Like there must be some sort of linear transformation that maps this region here. Yeah, it's like a shear transform or some shit, right? Like I can do a shear transform, and because my set is finite, that's okay. Where now instead of looking like that, it looks like that. And then, so okay, now we're in town. So let's take the projection of let's assume all the points have distinct XYZ coordinates, which we made by a suitable rotation. Take the projection down into XY space, sort them by X coordinate. So it looks something like this. And then pick some epsilon large enough, or pick some angle large enough that the V shapes at every point. In fact, it's actually easier if I let this one still be horizontal. Like pick some very large slope such that the I don't know, truncated something, but I don't even know what to call this. But pick it such that like all of these shapes have the property that when I look at any point, all the points to the right are in the corresponding cone. Cone? Cone? Can we call it a cone? Or, I don't know, what should I call it? I don't know what to call it. I hate this. Why did someone give you this problem to do? Anyway, it's fine. Call it like, also I'm off the screen. This will need a diagram, actually, in my solution. I don't know what to call it. Yeah, like things that look like this, okay? Like the point is we stretch it, and now we can assume every point contains all the truncated half plane. I don't fucking know. Okay, truncated half zone or something contains every point to its right. And now the argument that I had in green will work, because I can take the preimage of all the crappy other things, and yeah, I think we're okay. We're actually okay now. Yeah, I think this should work now, right? Because if I don't have quarters, I have like 1/2 minus epsilons. Because the set is finite, I can do a stretch that's good enough. And now when I'm here, like if I have v1, v2, I can have a thing that omits Is that true? I think so, right? It must be okay once I hit 1/2 minus epsilon. Like the issue I was having earlier was a quarter. Right, so now when I look at Vn, I mean, now I can actually even just use vanilla induction. I think it's like instead of a single f, I have this stretched f. We'll call it like f star or whatever. And again, the point of f star is to hit everything except Vn. But you apply some shear to f star such that its injective zone, which originally was just a quarter, is now a half plane. Because I've picked everything carefully, where Vn is to the left and its half plane contains everything, now I can do this, and then inside here, I use the induction hypothesis to avoid all the preimages of f star. Now we're okay. I think we won. Can someone check this? I think this works. I think the point is that I had this construction f and it was almost good because it got a quarter. It got a quarter, and a quarter is not good enough to force everything to be injective. Like the issue we kept having was that we couldn't chain the f because the injective zone was only like a quarter-ish of the points. But if I apply a shear transform on the outputs of f, then I can get the injective zone to be a half minus epsilon for any epsilon greater than 0. Once I can do that, I can sort all the points such that by, say, x coordinate, and then take the leftmost point, take its shear so that it can absorb everything to its right is actually in its injective zone. and then apply induction hypothesis, because now I actually have a unique preimage for every point in the injective zone for f. And that will do it, I think. Can someone yell at me if that's wrong? I don't know. I'm gonna just start typing this up, okay? How about I type this up? So the function that we chose was xy minus 1. Oh my god. It's x to the 4th xy minus 1 plus z squared plus x squared. Was it? I can't remember. Plus y. Z. The function f hits every point except 0, 0, 0. So it should hit every point except 0, 0, 0. And in addition, for points a greater than, with a greater than 1 and b greater than 0, f has exactly one preimage. Okay, so the proof is ignores. So we are essentially considering the system of equations so this is a equals xy minus 1, and then minus b is equal to x to the 4, xy minus 1, a to x4 plus z squared. If we multiply the now c squared x cubed, so we're gonna plus bx, and then x times y is a plus 1 to 0. So if any of a, b, c are non-zero, we get an odd degree polynomial in x, which manifestly should have at least one real solution in x. Such a value of x will then yield a value except when a equals, is it minus 1 or shiba xy a plus 1? What did I have in my slides? Crap, I shouldn't have closed the slides. Why did I write a equals xy plus 1? Hang on. Actually, it's fine. No, it's not fine. What the fuck did I do? Should this be a +1? Now I'm really confused. Why did I have a -1 here, and why is it changing the result? Okay, I'm going to change the -1 to a +1. I think that is fine. No, actually... So if a is, in the special case where a is -1, in that case, either x or y has to be 0. C squared x cubed, I don't... Oh, sorry, yeah, it should be z squared x squared. So in the case where a equals -1 and x equals 0, why is it... Or actually, I don't care about the unique value. Suitable value of y. In addition, the value of x is unique as long as a greater than 0. Has a unique solution. The quintic will have a unique solution by Descartes' rule. Unique real solution. So this does depend on real. So here's my function. And the sign error actually makes my life a little bit easier because now I don't have to. So we proceed by induction on. So the second main ingredient is this. Claim there exists a function f for every epsilon. There exists a function f f prime. Well, let me call it fg or something. Reaching every point except 0, 0, and such that g is injective on the region x greater than 0, y greater than what do I call it? Epsilon x plus y greater than 0. Proof. Apply a suitable shear transformation to F. Without loss of generality by a linear transformation, all the x coordinates, assume all the x coordinates, all the x, y, z coordinates, I mean, it doesn't matter. By matrix transform. I'm going to call it homography. And by translation, positive. By suitable, let me just say that affine transform. Okay, so if it's a single vector v, all we're going to do is take let f equals, we choose just f plus v. So assume s greater than 2. So assume the size of s is at least 2, and let v be, and without loss of generality, let v be the, well, let's call this n. Be the vector with the lowest x coordinate. I mean, this is a proof that it's injective, right? Because as long as A, B, C are all positive, Quintic has promised to have exactly one solution, and it's also promised that A is A plus 1 equals xy, so the unique value of x determines the unique value of y. Such that x plus epsilon y rest have A greater than 0. Oh, shit! Yeah, you're right. I should just apply a linear transformation to the points. Good. That's a good point. All right. Sorry. You're right. That's cleaner. You're right, yeah, I should apply the shear transformation onto S instead of to the function. That's easier to think about. Finally, We apply several transformations. So we assume they're all distinct. Finally, apply a shear transformation such that on the y-coordinates, such that all y-coordinates are positive. For m large enough. We observe technically I could merge the base case. Actually, I really just need the empty set can be the base case. I think I can technically write it this way, and it's a little. Okay, vector, vector, vector. Okay, no, I won't be a dick. We'll write the base case with one element. There's no reason to make the base case intentionally confusing. To So satisfying G of vec Wi. Satisfying F. Yeah. Hence, since the function, what is the name of this function? F G vector x plus, so this will omit all the VIs. Actually, that's just it, right? That's just fine. It's so short now that you read it. It really threw me for a loop. My God, we were fighting this for so long, trying to. The shear transformation. It's like first you have to construct one, and then you have to get an injective result on top of that for there, and then you have to apply a shear transformation so that your injectivity actually can cover. Because with a quarter. It looks so short now that I'm looking at it, but there's like three main ideas that happened. It's like how to avoid one, which is actually, honestly, that might have been the hardest part. So I'm lucky that one of the viewers figured that out. And then get an injective result. And then apply a shear so that you can read the points from left to right. And get pre-images for all of them under F. Well, we got super lucky because the construction that we had for F does have the injective properties that we needed as well. Alright, success. Amazing. Yeah, that... Alright, it's definitely bedtime. Oh my god. Omitting all... Oh. Do I classify this as algebra or combinatorics? This is that, or geometry. I don't know. Let's try through. Oh my god, that was a struggle. How long did that take us? Also, yeah, algebra. I was mostly kidding. How do I find RMM 3 on this? That's really fast, actually. So did anyone solve it in the actually, I don't know. Most people, oh, I know most people didn't solve it. I'm curious, did anyone solve it? Because this seems like, this is so long. What the heck? Okay, sorry. The solution is, when printed the solution is short. It's just there are 3 different key ideas and then none of them are easy. Maybe the injective one is because it's like if your construction doesn't have injectivity properties, you're just gonna die, right? Like it's already hard enough to construct like a map that misses 1 point, but now you have to construct a map that misses 1 point and has the injective properties you need, and then also figure out how to do the shear transform so that you can keep applying the injectivity. Although, I don't know, maybe the shear transform was okay, and I don't know. I feel like the viewers figured out the hardest part for me. Oh, cool. Do I have the shortest solution? Or, not shortest, but most natural? Or, no, maybe not. Probably not. I don't know, man. Oh, that's a lot of different solutions. What the heck? Okay, well, anyways. I'll better fast track this video to YouTube. Was rough. Alright, we did it. Good job, team. Alright. Okay, great. So that's that for those of you watching on YouTube. Thank you for tuning in. Congratulations on making it all the way to the end. That's probably a fairly boring video to watch. I spent so much time with the stupid squares. Oh my god. You just apply a shear transform. It's okay. Anyways. Yeah. Alright, cool. Peace out. See you all next time. Whew. What an adventure. A logic bingo.